Hi, this is a demonstration for Lab2. My name is Emrah Karagöz. In this Lab2, we are given two arrays and we are asked to copy them into new array 1s and array 2s, and we will do the sorting in array 1s and array 2s. Okay, so we are already given the copy function, copy subroutine. We will write the sort function. Okay, so let me first debug the function and give the results. Set stop. We cleared everything. Okay, we copied and sorted. Okay, so at 210, it becomes AEC9 D4 EDE10 18 2B 4D and 63. At 230, A6 B3 B4 0C 17 19 3C 3D 61 and 62. They are 62. They are the sorted version of array 1 and array 2. Now I will show how the sort function works. Okay, I will do soft reset. Okay. Okay, the address for array 1 is stored to R4 0200, and memory address 210 is stored at R6. Okay, we initialize this already initialized actually. Okay, we initialize the array 1 elements at 0 to 00 here, as you see. Okay, then we copy this array to 210 here. Okay, now we will do the sorting. I will step into the sort function. Okay, for the sort function, just focus on 210. Okay, now it's the original copy of array 1 for now. Okay, we start with, yes, yeah, it's better. Okay, so the number of elements are, R6 stores the memory address for array 1s. So the number of elements in the array 1s is 10, and it's going to be copied to R8. Okay, it's going to be copied to R8. Yes, it's copied to here. Okay, so I will also copy the address at R6 to R7, because I will use the R7 as the counter. Okay, and I will keep the original address at R6. Okay, so R6 and R7, they are now equal. R6 is copied to R7, and I will use the R7 as the counter. Okay, now R9 and R10. At R9 and R10, I will keep the swap value and the counter values. R10, it will start with 1, and in each step, it will increment by 1 until it reaches to the number of elements at R8, 1 2 3 2 1 2 3 4, until, for this example, it will be 10. Okay, the R9, it's going to keep the swap value, which means if there is no swap in the for loop, it's going to be 0. If there is at least one swap, then it will be 1. Okay, so in the for loop, I will change the R9 if there is a swap. Okay, but initially it's going to be 0 because there is no swap yet. Okay, now let's go after setting R9 and R10, the swap value and the counter value. Okay, now the value at R7 0. By the way, I increment the R7 to 211 here initially because I want to start with 2b. Okay, so 2b is copied to R11 and ED is copied to R12. Now we will compare R11 and R12. 2b is 43 and ED is -19, so they should be swapped. Okay, -9 and 43 should be swapped. Okay, here when I compare this, if the second video is greater than first video, which means there is no swap, so I directly go to the post swap. But if otherwise, I should perform these 3 lines, which represents the swapping of 2 values. Okay, so in this case they should be swapped, so I continue with the swap lines. R11, which is 2b, is going to the address of 4d, which is 213. Okay, you see 2b becomes here. I'm sorry, 212. And R12 ED goes to the address at R7. I mean here. You see, so the values here 2b and ED, they are swapped. Okay, then we go to next address by incrementing R7. Now we are at 212. We are at here. Okay, and we will compare 2b with 4d in the next step. Okay, but before we also increment the counter R10, and we need to compare R10 with the original number of elements, which is stored at R8, which is here. So since it's not reached to 10 yet, I go back to the for loop again. Okay, the counter in the for loop is R10 here. Okay, so again 2b and 4d, as I told before, 2b and 4d will be compared. 2b is 43, 4d is 77, so there is no swapping here. Okay, I compare them and I directly go to post swap because no swapping is needed. Okay, so I go to next address by incrementing R7. I also increment the counter R10. I compare the R10 with R8, but it's not reached yet. Okay, 3 not reached to 10 yet. So I repeat the for loop again. Now the values are 4d and d4, 4d and d4, 4d and d4. 4d is 77, d4 is -44, so a swap is needed. Okay, so we perform the swap lines, and as you see, they are swapped. Okay, and we go to next address and increment the counter. Now we compare 4d and 18. 4d and 18, we compare 4d and 18. 4d is 77, 18 is 24. 4d is greater than 18, so we need to swap them. Okay, we swap them. We go to next address. In the next address, we compare 4d and AE. 4d and AE, we compare 4d and AE. 4d is 77, AE is -82, so they need to be swapped. Okay, swap lines performed. We go to next address, 216. 216 is here. So we need to compare these two. These two values are copied to R11 and R12. Yes. R11 is 4D, which is 77. C9 is -55. So they should be swapped. Yes, they are being swapped. Okay, they are swapped. Now 40 and 10. Yeah, 40 and 10. 4D is 77, 10 is 16, so they should be swapped again. Yeah, they are swapped, as you see here. We go to next address. In the next address, 4D and EE, they are going to be compared. 4D is 77, E is negative 18, so they should be swapped again. Okay, we go to the next address, 4D and 63. Yeah, 4D and 63. 4D is 77, 63 is 99, so they're not gonna be swapped. So in this step, these 3 lines will be ignored and go to post swap. Okay, there was no swapping here. Okay. Now R10, R9 reached R8. R10 reached to R8, which is 10 equals 10 now. So we can finish the swap. We can finish the for loop here. And we need to decrement the original video for the number of elements by 1. It becomes 9 because the last 2 elements are in sorted now, so we don't need to go until here. Okay, so in the next for loop we just need to do comparison or swapping until here, not 63, until 4D. Okay, so do the same thing again. You see swappings. Yes, there are swappings. We do the swapping. This swapping, sort loop part ends when there is no swap. Okay, because we will come to some step such that they are all sorted. If they are all sorted, okay, if they are all sorted, then since we initialize the swap value by 0 in the beginning, okay, and we go into for loop, but if there is no swap, okay, which means R9 never goes to 1, never turns to 1, okay, which means they are all sorted. That's why I did the here. If there is no sorted, I mean R9 is 0, so we end the sort loop here. Okay, not for loop, the sort loop, and we return the sorted version of array. No need to swap elements anymore, so they are sorted. Okay, thank you so much for this. And we can also do the same thing for the other array. You see, they are sorted again. Yes. So this is the end of lab demonstration, lab 2. Thank you so much.